Lesson 3.1, Solving Quadratic Equations. How do you solve a quadratic equation by graphing and algebraically? Going over your independent practice problems. Problem number 11. The problem does not equal 0. We need to make it equal 0 or we cannot factor. So let's subtract the x squared and add the 1. 2x squared minus an x squared gives me 1x squared. Negative 50 plus 1 is a negative 49. My problem now equals 0. I see that I have two terms. If I have two terms and I know that it is subtraction, we're going to try the difference of squares. Can I take the square root of the front and can I take the square root of the back? The square root of x squared is x. The square root of 49 is 7. I can, which means this can be factored using the difference of squares rule. The front was x, the backs are 7. So I have two factors. Either this factor is the reason it equals 0, or this factor is the reason that it equals 0. So we need to solve for x on each. Two factors gave me two answers. Either x is negative 7 or x is positive 7. Independent practice problem number 12. This does not equal 0. I need to make it equal 0. So I'm going to go ahead and move the 3x to the other side. 3x squared minus 3x squared gives me 0. I have 81 minus 4x squared. So I have two terms. If I have two terms and it's a subtraction, I want to see if I can do factoring by difference of squares. So the square root of 81 is 9. The square root of 4x squared is 2x. I can do the difference of squares. So this problem originally equaled 0. I am factoring this using the difference of squares. The front was a 9. The back was a 2x. I have factored it. I have two factors in my problem. Both of those factors could be the reason why this problem equals 0. So you need to solve each factor for x. Two factors give me two answers. X is a negative 9 over 2, or x is a positive 9 over 2. Problem 13. I see that I do not currently equal 0. I have to equal 0 or I cannot factor it. So we're going to move the 80 to the other side. I have three terms. The only way to factor three terms is to do the A times C adds up to B list. Because A is 1, we know that this will factor without having to use the area model. The only way to get x squared is x times x. We have to do the A times C. Somebody better add up to B list to get these numbers. A times C is a negative 80. B is 2. I need two numbers that multiply together to give me negative 80, but add to give me 2. So let's go ahead and just come up with all the ways to multiply to get negative 80. These are all the ways to multiply to get negative 80. Now let's see which one of these will give me the 2. If I add these together, I get 79. That didn't work. Add these together, I get 38. That didn't work. Add these together, I get 16. That's not the 2 that I needed. Add these together, I get 11. Not the 2 that I needed. Add these together, I get the 2 that I needed. So the numbers I'm going to use are negative 8 and positive 10. So here's a minus 8 and my positive 10. Now that I have factored the 2, I see that I have two factors. Either the first factor is the reason that it's 0, or the second factor is the reason why it is 0. So we're going to solve for both. Two factors gave me two answers. X is 8 or x is a negative 10. Number 14. The problem currently does not equal 0, which means I need to move these things to the other side of the equal sign so it does equal 0. So I'm going to subtract the x and we're going to subtract 4. So I have x squared plus a 10x plus a 25 equaling 0. I have three terms, which means I'm going to have to use the A times C. Somebody better add up to B list. Because A is 1, I do not need to use the area model. I'm just going to factor it straight into the parentheses. The only way to get x squared is x times x. I have to do the list to find the numbers. A times C is 25, B is 10. What two numbers multiply to give me 25, but when I add them I get 10? 5 times 5 multiply to give me 25. When I add them I get 10. So this is a positive 5 and a positive 5. These are the two numbers that had to go there. Two factors meant that I need to find my two answers. So two factors give me two answers, just happens to be that they're the exact same answer. So my answer is x equals negative 5. Problem 15. My problem does not equal 0, which means I need to move these items so that it will equal 0. 2x squared minus an x squared gives me an x squared. Negative 9x's plus 1x is a negative 8x minus 65 equals 0. Three terms. If it is three terms, that means I'm going to end up needing to use the A times C, somebody better add up to B list. Because A is 1, I will not have to use the area model. The only way to get x squared is x times x. Now I just need to use the list to find these two numbers. A times C is a negative 65, B is a negative 8. So let's find all the ways to multiply together to get negative 65. Negative 1 times 65 will give me negative 65. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 works. Say negative 5 and a 13. 6 didn't work, 7, 8, 9, 10. These are the only two factors. So if I add these together, I got 64. If I add these together, I get a positive 8. I needed a negative 8. So I was really close. That just meant the negative was on the wrong number. So 5 times a negative 13, they still multiply together to give me negative 65. When I add these, I get a negative 8, which is the number I needed. So these are the two numbers I'm going to use. That is a positive 5, and that is a minus 13. I have two factors. If I have two factors, then I have two answers. Two factors give me two answers. My answer is x equals negative 5 and x equals 13. Your last independent practice problem. It needs to equal 0. So we're going to move these items over so that it equals 0. 4x squared didn't have any more x squareds. 41x plus 3 more x's is a 44x. Positive 98 minus 2 is a positive 96. This now all equals 0. I see three terms. If I have three terms, that means I'm going to have to use your A times C, somebody better add up to B list. These numbers are really big. So I am actually hoping that there's a GCF. So let's see if there's a GCF in common with any of these. And I see that all of these can be divided by 4. So if I factor a 4 out of everybody, I get x squared plus 11x plus 24 to equal 0. Factoring out the 4, I don't need to use the area model anymore. I can just come down with my parentheses. A times C is 24, B is 11. Because we factored out the 4, our list is going to be incredibly easier to do. The only way to get x squared is to have x times x. So now I just need to figure out what these two numbers are. What do we multiply together to get a positive 24, but when I add them I get 11. 8 times 3 multiply together to give me 24, and when I add them I get 11. So a positive 8 and a positive 3 are the numbers I'm going to use. I see three terms. I see three factors, and all three of these factors are the reason why the problem is 0. So we need to solve for x on all three of them. 4 will never equal 0, so this factor does not give us any solutions. The other two factors gave us solutions, negative 8 and negative 3.